In this video we're going to be talking about some triple content from the B5 topic, and that's control of body temperature. You can see in this picture we have the network of capillaries, blood vessels going through the hand, just for you to get an idea of just how vast the network is. And with all control systems, we've got receptors receiving the information, coordination centres, in this case it's the thermoregulatory centre in the hypothalamus in the brain, and the effectors, and in this case we're going to be talking about the muscles surrounding the blood vessels which are able to contract or relax to control the amount of blood flow. Things that we already know about before we entered the topic are the idea of the hairs. So hairs on our arms can stand up on end when we're cold to try and trap as much heat as possible, and they can lay flat when we're trying to lose some heat because we're too warm. We've also got the method of sweating. On the right hand side of this picture you can see a sweat gland, and that's surrounded, kind of knotted round the blood capillary. So as the warm blood travels through that capillary, some of that heat transfers to the sweat gland, and then sweat is released as it evaporates from the skin, taking that heat away with it. We also know about shivering. Shivering is where the muscles contract close to the surface of the skin, releasing energy as heat to try and keep us warm. Those are our methods that we know about before we started this topic. Now we're going to have a look at vasoconstriction and vasodilation. In vasoconstriction, the blood vessels are constricted. How does that happen? So the muscles either side of the capillaries, just here, contract. The muscles contract, and that causes the capillary to constrict. It reduces the blood flow through that capillary and therefore reduces the heat loss to the surface, through the surface of the skin. So we're talking about in our hands, in our feet, nose, ears, all of our extremities. A good way of remembering vasoconstriction is vasoconstriction, which has a C in it, is when we are in a cold environment. C again. It is contraction of the muscles surrounding that capillary, and it constricts the blood vessels. So it's all the C's together: cold, contract, constrict, vasoconstriction. When it's too hot, and sometimes if you wear jewellery you'll notice this, your rings become quite tight because your blood vessels are dilating. Those muscles around that capillary relax. This causes the blood vessel to dilate, which means to become bigger. More blood circulates through those capillaries, and then more of that heat is transferred out of the body through that close contact with the skin. So, in summary, cold conditions, the muscles contract, which means less blood will flow through the capillaries because they're constricted. And it's really important because it's keeping all of that heat in the organs of the body to ensure that everything's at the right temperature, and in particular, enzymes can work efficiently. In hot conditions, the muscles relax. That allows the blood vessels to dilate and more blood to go through those capillaries, losing some of that heat. In extreme cold conditions, we can get frostbite. Now, what this links to is that sometimes we are so cold, we need to keep as much heat in as possible, and the blood, rather than just being constricted by those muscles, it actually completely diverts those capillaries that go through the fingers, and it goes through a shunt vessel. So this is where you might get frostbite and fingers die, become blackened and have to be removed later on. But this is completely redirecting the blood flow so that it's like the extreme method of maintaining that body temperature. So here's our final summary. In the top left there we can see about muscles rapidly contracting, causing us to shiver, and the heat energy released used to keep us warm. We talked about vasoconstriction, where the muscles contract, causing blood vessels to constrict, and then conserving heat. That was all the C's. And the hairs, hair muscles contract so that heat is trapped. That's when our hairs stand on end. If we're too hot, then sweat glands release sweat, which evaporates, and we saw how the sweat gland is kind of knotted around the capillary. Vasodilation, where the blood vessels dilate, they get wider because those muscles either side have relaxed. And then we also talked about the hair muscles relax so that the heat can escape. That's when our hairs lie flat. We can look at this as a negative feedback loop. So if we're too cold, those blood vessels constrict, causing the vasoconstriction to occur, regulating our temperature, keeping that warmth in. And then if it's too hot, they dilate, allowing some of that heat out to, again, bring us back to the same situation. When we think about negative feedback, we just have to think about we're in a negative situation, we're sending some information, giving some feedback, and then we're looking at correcting it. Hope you found that useful. Thank you.